Hello everyone, welcome back to another session of construction planning. Students, in the previous session of construction planning, we have started learning about the numericals based on drawing the network. Yes, we have started with the numericals, and in that numericals, we have started discussing about first two categories. The first one was in which the data was given in numerics, and the second in which the data was given in the tabular form. In that data, in that table, the predecessor activity or successor activity data was given for the particular activity, and we draw the network for such data. So I hope we are clear about it. All right, so today in this session we are going to learn, yes, we are going to continue with the numericals of data given in predecessor or successor activities. Then today we are going to cover up a very important topic, that is dummy activity. After learning the certain things about dummy activity, we are going to see the numericals based on dummy activity, and the last category of numericals, which is data given in directly event numbers. So we are going to see the third category today as well, that directly event numbers are given to in the question. So let us continue with another question of drawing up the network. But before we start any network, or before we start learning, before we start discussing any question, let us see the few of the points which are needed to be discussed. The first point was that network should consist one single initial node. Network should consist only one final node. It should have only incoming arrows, no outgoing arrows should be there in one final node. Number of activities should be number of arrows. Then there was a rule, there is no backward or looping is allowed, only forward path is allowed, and the dummy activity is to represent the the logic, maintain the logic of the network, or to avoid the duplication of any activity. So these are the basic rules which we need to keep in mind while drawing up a network. So let us see a question. So as you can see, here is a question in which a tabular form is given where activity and predecessors are two columns. A, B, C, D, E are the activities, and in the predecessors column, students, as you can see over the screen, activity A, B and C are having no predecessor, while activity D is having predecessor as activity A and B, while activity E is having predecessor activity B and C. So as we know that how to solve this network, we always read two or three datas. When in tabular format, you need to take two or three datas at a time to draw the network. So here, as you can see in the question, that activity A, B and C are having no predecessor. What does that mean? Activity A, B and C are having no predecessor. That means they are the first activity of the network. Let us draw it. So as you can see over here, this is how we'll represent the activity A, B and C, that they are the parallel to each other and they are starting together. Now let us come back to the question. The next activity is activity D, and predecessor of activity D is activity A and B. So now let us represent this scenario. So here is the representation that D, successor of D is A and B as well. So I have represented D two times in the network. But again, you know that is not possible. So in the previous session, we have learned, or we have used the tactics that we need to check that we could merge the endpoints of A and B or not. Let us do that. So if we merge the endpoints of activity A and B, it will look like this. So starting point of activity A and B are the same, as well as ending point of activity A and B are the same. But this is not possible in the network. This is known as grammatical error in the network language. Yes, an activity cannot have same starting point and same ending point. So that is an error. In the previous sums, this was not an issue because both we are merging the endpoints, but the starting points were different of two activities, and we are only merging the endpoints. But now here in this case, while we merge the endpoints, the starting points are the same. So this scenario cannot happen in the network. So what we do now? There comes the logic of, or there comes the concept of dummy activity. Let us see. A dummy activity is similar to a activity which does not require any time or resource to complete. Yes, it is a dummy activity which does not consume any resource or time. It is just there in the network to maintain the logic and interrelationship between the activities. A dummy activity is represented by dashed arrow line in the network. Now, use of dummies can be done in two cases. First, grammatical purpose, and second, logical purpose. So that is your dummy activity. In such cases, the case which we have just seen ahead, that we cannot merge the endpoints, because while merging the endpoints of activity A and B, it becomes starting and ending point of the activity same. So that is known as grammatical error, and such for to reduce, to minimize, or to to draw the network correctly, now we need to introduce the dummy activity. So first, let us see the grammatical purpose. So here is the statement of the grammatical purpose, that two activities cannot have the same starting and the same ending events in a network, which may cause an error in the network, which results into the error in the network. Yes, two activities cannot have the same start and same end. Focus on my words, students. For two activities, start and end both should not be same. Either only to start should be same and end should be different, either end should be same and start should be different, but start and end cannot be same. That is your grammatical error. Now, how to solve this grammatical error? Let us see. All right, so this was the scenario which we are stuck at, that A and B are the same. So this cannot happen. So what can happen? So as discussed, that either start should be the same and end should be different, or start should be different and end should be the same. But both of them cannot be represented at the same time. So now here in our case, let us introduce a dummy activity. So here is the correct representation of the dummy activity in our network diagram. We know that there were two activities A and B. A and B. Now activity D was coming out from activity A and B, but we cannot merge the endpoints of that activity. So we are connecting a dummy activity from A to B. You can see that in the dummy activity, the arrow is downward. So A to B, the dummy activity is A to B. Now in simpler terms, in our language, I'm not talking about the project management language, but in our normal language, this can be termed as temporary shift, that we are temporarily shifting the endpoint of A to endpoint of B. So now, while it is temporarily shifted through the dummy activity, now from that from that head event of B, I can drag the activity D ahead. Let us see. Now, let us see the logical purpose of the dummy activity. So the logical purpose of the dummy activity says that two activities cannot have the same name in the network diagram. That means an activity can only occur once in a network diagram. If there is a situation where you have to represent the activity twice, you need to draw a dummy activity and you need to connect the diagram with the use of dummy activity. Let us see an example. Alright, so here is an example where you can see the activity L is coming twice. Now, that is against of rule. You cannot represent an activity twice in the network diagram. So, all you need to do is you need to create a dummy activity for either of one, and you need to connect it by the dashed arrow line. We'll see the logical purpose in numerical again. Now let's come back to the numerical in which we are about to use the dummy activity. So we were stuck at here that activity D was coming out from activity A and B. So as you can see on my screen, I have represented the dummy activity from B to A. From B to A. That is known as temporary shift of the head event. So I have shifted the head event of activity B temporarily to activity A. So now I can drag, or now I can draw the activity D from activity A. So that is how we'll use the dummy activity. I hope we are clear about the concept of dummy activity. Now let us see the question again and complete the sum. So the last activity was activity E, and the predecessor of activity E was activity B and C. So now when you are talking about activity B and C, again the same scenario happens. Let us draw it. So here, as you can see, that I have represented a dummy activity from B to C. That means I've shifted the head event of activity B temporarily to activity C. So now I can draw the activity E. So that is your last activity E. But now here again there are two endpoints above activity D, and there is activity DE. So D and E, two endpoints cannot happen. So I have to merge the endpoints of that activity D and E. Let us do that. So this is the correct representation of the network with the use of dummy activity. I hope we are very much clear up to this point that activity A, B and C are the initial activity in the network. Then from activity D has the predecessor as activity A and B. So I have represented dummy from B to A. Now activity E was having predecessor as activity B and C. So I have represented a dummy activity from B to C. But now here, students, you may think that what if the dummy activity should be to be represented from A to B instead of B to A? What if the dummy activity is represented from A to B? Let us see. So if dummy activity is represented from A to B, your network will look like this. So this is an answer number 2. You can draw the dummy like this as well. So there could be another option that what if I represent the dummy activity from B to A and the dummy activity from C to B. Let us draw that. So here is the third option of our network. So you can draw either of it. 3 of the options are the correct for the drawing of the network. Now let us see another sum. So here is a question given to us in which there are 3 columns: activity, predecessor and successor. and we need to draw the data, and we need to draw the network, we need to draw the network for the same. So here activities are from A, B, C, D up to G. I'm not reading the entire question. We are taking up one or two data at a time. So first, talking about the activity A, there are no predecessor, and the successor of activity A is B and C. The successor, that means following, that means B and C is following activity A. So let us draw this scenario. Predecessor, that means activity A has no predecessor. That means activity A is the first activities and being followed by activity B and C. Let us draw this scenario. So this is our starting of the network, that activity A is the only activity in the starting, followed by activity B and C. Let us see that. So here is the activity A followed by activity B and C. Now let us come back to the question. Now let us talk about the activity B. Activity B is being followed by activity D and E. Students, when you are given the data of predecessor and successor, both kind of activities, you need to focus only on one. Either you prepare the network on the basis of predecessor, either you prepare the network on the basis of successor. That will be easy for you. So we are looking at the successor. So successor of B is activity D and E. Let us draw that. So as you can see over here, from activity B, there are two arrows coming out of activity D and activity E. Now, let us come back to the question again. So the next is activity C. So activity C has successor activity E. That means activity E is also coming out from activity C. Let us see this. So when we draw the activity E from activity C, this scenario happens, and this is not correct because activity E is appearing twice. Activity E was coming out from activity B and activity E was coming out of activity C. So activity E cannot represent twice. So that is our logical purpose. So we have to introduce a dummy activity. Let us see that how we can represent this scenario using dummy activity. Here, as you can see that I have drawn a dummy activity from B to C. From B to C. And then I have represented the activity E. The reason that why I have not represented C to B is if we shift the head event of C to B, that means now C and B are the same. So D and E are both coming out of C. But C should have only followed by E. So we need to drag down the downside the arrow. So I've drawn the dummy activity from B to C instead of C to B. I hope we are clear about this logic. Now let us read another data. So the next activity is activity D, which follows the next activity D has the following activity F. So let us draw that. So here is the representation that activity F is coming out of activity D. That was easy and simple. Let's come back to the question. Now activity E has the following activity as F and G, and activity F and G are the last activity. Activity E has the following activity F and G, and F and G are the last activity as there are no successor activity of them. So let us represent this scenario. So as you can see, F and G are coming out of activity E, but again F is being represented twice. So we need to draw another dummy. Let us see. So here I have represented a dummy activity from activity E to D, and then I have represented the activity F and G. Students, here I'm repeating it again. What I've done is I've represented a dummy activity because F was coming twice. So I've represented a dummy from E to D because because if I represented downwards, what happens? D has the follower F and G. but D has the only following F. So to maintain that logic, we need to draw the arrow upwards. So this is how we have represented the entire network diagram. And the next is numbering of the events. Let us see. So here is the actual network with the event numbers. Now students, let me tell you a fact that dummy activity does not have any time and resource, and you don't have to name it any. Dummy activity, you don't have to give any name to that activity. You don't have to even write the dummy activity. You have represented it by dash, that means that is dummy activity. So this is how the concept of dummy activity works. So I hope we are clear up to this point. Now let us see the third category of numericals, which is data given by directly event numbers. So how this data works? Let us see a question for that. Alright, so here is the question for the third category of numericals. As you can see, there is activity A to L shown in the table, and against of it you can see a column of identity, in which you can see there are numbers given. For activity A it is 1 2, for activity B it is 2 4, for activity C it is 2 3, for activity D it is 2 7, and so on. So this is the easiest type of the data. Here you are given with the circle number, that 1 to 2 is A, 2 to 3 is B, 2 to 4 is C. As simple as that. So all you need to connect the arrows. You don't have to think a lot of logic to draw the network, that who is following who, because here the direct circle numbers are given. So let us draw for this data. Alright, so first data was activity A 1 to 2. Then there were three datas start as activity as event number 2. 2 to 4, 2 to 3, 2 to 4, and 2 to 7. Let us represent that. So here is that activity B 2 to 4, activity C 2 to 3, and activity D 2 to 7. Now let us see the question who has the event number 3. So as you can see in the question, there are two activities E and F, 3 to 4, 3 to 5. Let us draw that. So this is how we'll represent 3 to 4, 3 to 5. Now again come back to the question. Now again we are taking three activities G, H, I. G 4 to 6, H 5 to 6, I 5 to 7. 4 to 6, 5 to 6, and 6 to 7. Pardon me, 5 to 7. So let us draw that. So that is 4 to 6, 5 to 6, and 5 to 7. So that are our three activities. Now let us draw the remaining part of the network. So the remaining part of the network is 6 to 8, 7 to 8, 8 to 9. So let us draw that. So that is 6 to 8, 7 to 8, and 8 to 9. And you are given with the activity numbers. So we can draw the network very easily by using event numbers. So when the event numbers are given, that can be considered as one of the easiest type of the data. So I hope we are clear up to this point. So this is it. That was all about in today's session. In case of any query or doubt, you can always contact me on my mail or my number. Thank you.